Despite the fact that Stephen Hawking is sadly no longer with us, the tradition of the splendid astrophysicist lives on. The profoundly anticipated mission of the James Webb Space Telescope will be devoted to exploring some of the enthralling theories of the late English researcher, who passed away in 2018, and putting them to the test. Among these is the proposal Hawking worked on shortly before his death, an extension of the compelling multiverse hypothesis. We will now delve into what this intriguing idea is about and how the James Webb Space Telescope can contribute to proving the assertions of the remarkable physicist. Want to learn more about the notable discoveries and baffling phenomena in the universe regularly? Then remember to subscribe to Essentially Space and click the bell icon to stay updated. By giving us a thumbs up, you're supporting us and showing us that we can keep you engaged with the content of our videos. Music. Another chapter in space exploration. After years of delays and unprecedented cost overruns, the time had finally come. On December 25, 2021, the James Webb Space Telescope left our blue home planet and set off on its journey into the vast expanses of the universe. The intricate technical device reached its planned destination, a distance of about 900,000 miles, the so-called Lagrange point L2, on January 24, 2022. The planned utilization of JWST is nothing less than elevating our understanding of the formative processes of the universe to a completely new level. The focus will be on the search for the first luminous objects and galaxies formed shortly after the Big Bang during the so-called Dark Age. In other words, the Space Telescope, developed through a collaboration between NASA, the ESA, and the Canadian CSA, will give us an authentic impression of how the universe appeared 13.5 billion years ago. It will be some time before the device, named after former NASA Director James Edwin Webb, transmits its first groundbreaking research results to Earth. The meticulous alignment of its advanced components will take several months. If all goes according to plan, the most powerful space telescope ever built will begin its scientific observations in June of this year. Why are experts so excited about this new chapter in space exploration? The answer becomes clear when we consider the precision with which the space telescope will operate. JWST will be up to 100 times more sensitive to electromagnetic waves than the Hubble telescope. Equipped with these advanced capabilities, the James Webb Space Telescope will offer an entirely new perspective on the solar system, allowing us to thoroughly examine the innermost regions of star-forming zones and analyze the material composition of exoplanet atmospheres more precisely than ever before. The instrument's ability to provide revolutionary insights into the past of the universe stems from its capability to analyze wavelengths from visible red light to mid-infrared light. Light emitted from distant, and thus particularly ancient, regions of the universe is typically shifted into the infrared spectrum by cosmological redshift. Infrared radiation, also emitted by cooler structures, can penetrate interstellar gas and dust clouds in space far better than visible light. To ensure the telescope's instruments function seamlessly, they must be kept extremely cold. Specifically, they must remain below -433 degrees Fahrenheit. This is made possible, among other things, by the telescope's imposing sunshield. As we can see, the JWST is poised to reveal some previously unknown secrets of the universe in the near future. It may also bring us closer to answering one of the most central questions in modern space research. What is the true structure of our cosmic home? Is there such a thing as a singular universe, or is our cosmic residence merely a tiny fragment of an unimaginably vast overall construct? Hawking's legacy. The last technical paper to which Stephen Hawking devoted his life was completed just days before his passing and later published by the paper's co-authors. The article proposes an alternative solution to the information paradox in black holes. According to this theory, the missing information resides in the photons near the event horizon of these immense gravity wells. The final paper submitted by Stephen Hawking for publication also revisits his earlier no-boundary proposal for the origin of the universe in detail. This remarkable multiverse hypothesis predicts eternal inflation, accompanied by an infinite number of newly forming baby universes. As the term multiverse suggests, this theory posits that our universe, with its galaxies, billions of stars, and other celestial bodies, is not the only one. Instead, it represents just a vanishingly small link in an infinitely vast chain of universes. Furthermore, this hypothesis suggests that many of these other universes follow their own physical laws, which may differ drastically from the patterns observed in our home universe. One particularly astonishing aspect of the multiverse hypothesis is the notion that, in the vastness of universes, each of us has a perfect double. Put simply, in a realm of infinity, everything that can exist does exist. Despite the fact that Stephen Hawking is tragically no longer with us, the tradition of the splendid astrophysicist lives on. The exceptionally anticipated mission of the James Webb Space Telescope will be devoted to testing some of the captivating theories of the late English researcher who passed away in 2018. Among them is the theory on which Hawking worked last before his demise, an expansion of the multiverse hypothesis. We will now show you in detail what this intriguing idea is about and how the James Webb Space Telescope can contribute to validating the claims of the remarkable physicist. Want to learn more about groundbreaking discoveries and mysterious phenomena in the universe on a regular basis? Then remember to subscribe to Simply Space and click the bell to stay up to date. By giving us a thumbs up, you motivate us and show that we can keep you engaged with the content of our videos. Another chapter in space exploration. After years of delays and unprecedented cost overruns, the time finally came on December 25, 2021. The James Webb Space Telescope left our blue home planet and embarked on its journey into the vast expanse of the universe. This complex technical marvel reached its intended destination about 900,000 miles away at the so-called Lagrange point L2 on January 24, 2022. The planned mission of JWST is nothing less than elevating our understanding of the formation processes of the universe to an entirely new level. The primary focus will be the search for the first luminous objects and galaxies formed shortly after the Big Bang, during the epoch known as the Dark Ages. This space telescope, a product of collaboration between NASA, ESA, and the Canadian CSA, promises to provide us with an authentic glimpse into how the universe appeared 13.5 billion years ago. It will be some time before this device, named after former NASA Administrator James Edwin Webb, transmits its first significant scientific findings to Earth. The meticulous calibration of its advanced components will take several months. If everything goes as planned, the most powerful space telescope ever constructed will begin its scientific observations in June of this year. The significance of the James Webb Telescope's deployment becomes apparent when we consider the precision with which it will operate. JWST will be up to 100 times more sensitive to electromagnetic waves than the Hubble telescope. Equipped with these advanced capabilities, it will observe the solar system from an entirely new perspective, examine the innermost regions of star-forming areas, and analyze the material composition of exoplanet atmospheres with unprecedented accuracy. The telescope's ability to offer revolutionary insights into the universe's past lies in its capacity to analyze wavelengths from visible red light to mid-infrared light. Typically, light from distant and thus ancient regions of the universe is shifted into the infrared spectrum by cosmological redshift. Infrared light is also emitted by cooler objects and penetrates interstellar gas and dust clouds far more effectively than visible light. To ensure that JWST's instruments function flawlessly, they must be kept extremely cold, below -433 degrees Fahrenheit. This is achieved, among other things, by the telescope's imposing sunshield. With its incredible design and technology, the JWST is poised to uncover previously unknown secrets of the universe. It may even bring us closer to answering one of modern astrophysics' most fundamental questions. What is the true structure of our vast cosmic home? Is there really such a thing as a single universe? Or is our cosmos merely one small part of an infinitely larger multiverse? Hawking's legacy. The final technical paper to which Stephen Hawking devoted his life was completed just days before his passing and published sometime later by his co-authors. This paper presents an alternative solution to the information paradox of black holes. According to this idea, the missing information resides in photons near the event horizons of these gravitational giants. Hawking's last contribution revisits his earlier no-boundary proposal for the origin of the universe. His multiverse theory predicts eternal expansion accompanied by the formation of an infinite number of baby universes. As the term multiverse suggests, this theory posits that our universe, with its galaxies, countless stars, and celestial bodies, is not the only universe. Instead, it represents a minuscule link in an unimaginably vast cosmic chain. Fascinatingly, this theory also implies that many of these other universes may follow their own distinct physical laws, radically different from those governing our universe. One particularly intriguing aspect of this infinite multiverse is the possibility that somewhere out there, each of us has an exact double. In simple terms, where infinity prevails, everything that can exist does exist.